Hello everyone, you are welcome to the very first part of working with numbers. Here we'll be focusing on arithmetic operations, addition, division, multiplication, subtraction, integer division, exponentiation, and how do you work with input. These are basic things that we can do. So let's dive into this straight away. I start with addition. I have set up my files. All of them have some parameters set up in them to make it easy for me to just demonstrate to you how things work. So I need to minimize time that could be wasted in typing. So I already typed out some basic things. I'll just show you what the major message is. So all these files have their input already set up for them. You can change the values, and here I want to demonstrate addition operations. So what do we do here? The task is to add two numbers together to get a third one. So I'll say x plus y is what we want to do, and when you add x to y you get the result. And in this second or this last part we are displaying the result. Now this method of displaying result is a bit uncommon. I decided to introduce it just for you to see how powerful it is. I will run this and you will see what the result will look like. If I come in here and I say run Python file, it says x plus y is equal to 5, and people will be like, no, that's not what we were expecting. We were expecting to see print the F notation, and inside the curly bracket here we were expecting result to be put in there. Yeah, if you put result there, what you will find will be, it will just tell you 5, and that's not so interactive. This is an amazing way of displaying your result. There is another way you could have done that. You could have said print, then F notation, then you say x plus y is equal to result. Okay, this is print, not print. This is print. This is also going to work if you run it. Let me clear my screen. If I run this code again, you'll see 2 plus 3 is equal to 5. So you're free to pick whichever notation works best for you, and you'll be fine with it. So I can copy this and I take it with me when I get to subtraction, which is supposed to be the next task. Here, sorry, we are subtracting one number from another, so it will not be x plus, rather it will be x minus, and then you do the same thing here. So the task to be performed is to say x less y. We are demonstrating the use of the operator, and when you do that carefully, you will get the result of 2 minus 3, which is going to give you minus 1, if I am correct. So let me go in here, and it tells me x minus y is minus 1, 2 minus 3 is minus 1, which is in line with what we had in mind. If you go quickly to multiplication and you change the symbol here to multiplication symbol, we want to demonstrate that task of saying x times y. Remember I mentioned when we were talking about operators that the multiplication operator is the asterisk. So I've done the same thing here, and my second way of displaying the result is to put asterisk here. And when you run this, it will tell you 2 times 3 is equal to 6, I suppose. Yeah, so that's correct. We get the result that we want, and that is awesome. So we've done addition, subtraction, and multiplication. The next thing we need to focus on here will be division. Division is unique, but you will see what is unique about it now. What's the symbol for the operation? It is this. You won't see the standard arithmetic division sign that has dot on top and the lower side here. So if I want to say x divided by y, this is the way I will write it, and it will give me my result. And we can change the concept by coming around and then displaying this result in another way, and when you run this, it will give you the result of x divided by y, and 2 over 3 is indeed 0.6666 to infinity. That is awesome. Let's say we change this number and we swap this to be 4 over 3 and we run the code, we'll get the result as 1.33. But if you take this entire code, for instance, and you go into integer division and you overwrite what is there, what you then have is, I do not want all this 1.33. I do not want the 0.333 part to show. I only need the 1 or whatever the original integer is. What I'll do is to just put this symbol here. And this is the integer divisor. It will truncate whatever you have at the end of the original number. If I look at this and I run the code, I'll get 1. It will discard the point, whatever part of my result. This is an extremely powerful construct. If we understand it, we will be able to use it well. I think the next element that we need to think about here will be exponentiation, which is a way of saying I want to raise one number to the power of another one. So I mentioned to us during operators that this is not asterisk twice. That is the symbol that we use for that. And if I want to say 2 raised to power 3 or x raised to power y, to be x asterisk asterisk y. And if I run this, it will tell me 2 raised to power 3 is 8. And that is indeed correct. So that's the way to raise one number to the power of another number if you are using this symbol. It's not the only approach, but it's the common way of doing that. The next element in this series will be modulus. And modulus is talking about you dividing one number by another number and then returning the remainder. What is the remainder of you dividing x with y? So if I put x as 5 and I come into my task and I say x modulus y, what it will do is it will divide 5 by 3. 3 goes in 5, 1, and there is 2 left. So the result is going to be 2. And that is what we are interested in seeing. If I run this, it tells me x modulus y is 2. So this is the way you can get the remainder of dividing one number with another number. Now, it's not in all situations that you will see your figures or your integers or your float being given a number or numbers when you create the variable. You don't initialize all of the time. Just like we did in strings, I told us that it's possible for us to capture the input from our users directly. So how do we go about doing that? I can bring in the input function here and I'll say, rather than you initializing x and y this way, so why don't you say x is 0 at the initial stage, y is 0 at the initial stage, and then I can come in here and say input face. Here I can say x is equal to input, and it's asking me what message do you want us to indicate. We can say value of x, and then you close the bracket. Sorry, I should have opened the bracket at the beginning. And then value of x, we want it. Users will supply that. Then we need another input statement, and we'll say value of y, and then users will give you both. So when you get these two side by side or one after the other, the task that you need to perform if you are doing addition is to now say x plus y. It gives you the result, and then you are displaying the result here. When you run this in Python, I can even go as far as saying, okay, put my carriage return there to put my cursor on the next line. This is just fanciful, decoration of the code. If I run this, everything will work up to a point, but the result is not going to be accurate, and you'll be surprised. The code looks clean, but the result is not going to be accurate. So look at this value of x. I put 3 for x, value of y, I put 5 for y. In our minds, we are expecting the result to be 8. But look at what Python gives us. It says x plus y is 35. That is bizarre. That's not what we were expecting. We were expecting 8. So where did 35 come from? You look through the code, everything looks clean. X is an integer, and then we are getting the input here for x, we are getting the input here for y. We got 3, we got 5, we added them together, we should get 8. So why 35? The 35 is coming in because this operation being done here is being done to join x to y. Because of what? Because we have captured values of x from the keyboard. Same thing with the value of y. We need to convert whatever we capture into numeric format. So if you are dealing with integer, then you will need to, we'll say cast. You type cast in here. That means you are converting one variable format to another. In this case, we're converting from string to, text. Sorry, to integer, because this is the integer that I have here. I will have to do the same thing for y quickly. And then when we run this again, we will type in our 3 and 5 as we did before. Python will now convert what we type as 3 that would look like this to the program, and this one that looked like this to the program. Both of them will be converted to their numeric format, which will be, for sake of illustration, 3, and this one will be converted to 5. And then 3 can be added to 5 to get 8. But if you do addition of this to this, what you will get is 35, as we did before. So let's run this code now. I'm very confident that we will get the desired result. So we go ahead, it's asking us for the value of x, we put 3, value of y, we put 5, and then x plus 5 is 8. This is what we had in mind, and it's pretty amazing. So in this first video, we've been able to see how you can add two numbers together to get the third one, and then we saw how you can beautifully format the results. We went through addition, subtraction, multiplication, exponentiation, division, and the special kind of division when you want to return the integer number. And then we went through modulus, where you can see the remainder of dividing one number with another. And then last but certainly not least, we demonstrated how you can, accept input from your users rather than, initializing the variables with some values and then run with it. That's not what you will see in the real world environment. I hope you find these examples very useful. I'll see you again in the next video, where I'll be talking about some math functions that are beyond arithmetic operation. Thanks a lot. I see you there. Bye for now.